Hey, Matt. Hey, Andrew.
Hello.
Hey, this is Andrew Fanara. Hi, Matt. Hey, folks. Are we on for today?
I don't actually know. Um, it's a good question. Seems like pretty low attendance right now.
And I'm new to the group, so I have nothing to bring to the table.
Right. Yeah. And this is the general call. Yeah.
I think that's what I saw.
Yeah. It's possible that it has been
I didn't.
canceled or that was discussed. But I don't know. I'm a little semi in the loop. Um, who are you with, Andrew?
I'm an advisor to an engineering firm out of Seattle called Casney Engineering, and I'm also affiliated with another consulting firm that has as its client, one of its clients, the largest North American greenhouse operator, and so you might infer from that why I'm on this call.
Uh, yeah. Yeah, interesting. Greenhouses are interesting application. I don't know how ideal, but not. You might as well. You might as well, right?
Yeah, I mean I don't think it's technically a very difficult problem, but it's starting to resonate. I think its time has come, and I think if there's one thing the data center industry needs right now is a good story to help buffer the concerns about lack of jobs that they bring, etc. And the food security angle is kind of an interesting one.
Yeah.
How about
Yeah.
yourself, Matt?
I'm also an engineering consultant, doing so right now working for the largest Bitcoin miner in the US, which is also um, in the process of pivoting to AI, like inference AI, edge compute stuff.
Sure,
And my focus is, has from the start been waste heat export
sure.
applications and business case and all that stuff, the full value proposition. So now I'm specifically I've spent the year looking at the Bitcoin mining case, which is, in my mind, the sort of superior case. Um, and that was what sort of brought me into the industry. But now I'm specifically looking at edge compute and the sort of suitability of that for waste heat export.
Mm,
And yeah, that pretty much sums it up.
gotcha. I'll make sure I send you a LinkedIn connection.
Yeah, yeah, yeah.
Looks like there's two S's in your name, right?
There are two S's,
Gotcha.
excessive S's.
Yeah, Matt, like last times uh yeah, your inputs on um why Bitcoin mining, like the higher temperatures might be a better use case for heat reuse. Yeah, that was something interesting. You mentioned that the temperatures, these ASICs go to, or like the output temperatures of liquid goes to 70 C, right?
Yeah, there's even one that can approach 80, which
Wow.
is very useful heat in liquid form. Yeah. Yeah, and fundamentally, I don't think these ASICs or these computer circuits are very different from any others. I think they just don't have uh, the failure rate requirements. So you can kind of run them hotter because you're not you don't need sort of 5 nines of uptime, that kind of thing. They're expensive, but they're not as expensive as modern GPUs. So I think it really just comes down to sort of failure rate tolerance, but that is what they're doing. There are, lots of inexpensive air cooled machines, and those are the ones that would be appropriate for greenhouses for the most part. But I'm really only looking at the liquid cooled stuff. So yeah, the hot outlet temperature is ideal. Um, the fact you've got sort of low security and data requirements means you can build them, right into a central plant, or right, on site wherever you want. Um, and I guess the other thing is that you can size them for the heating load as opposed to sizing them for your compute workload, which is also ideal. So if you need 1 megawatt or less or more, or whatever, you're sizing it perfectly for your base load, to match that. And they're running all the time. So
Yeah.
you are not sort of beholden to the uptime that is driven by um, clients, or basically the end user who's doing the compute, whatever that compute is, right? They're, not necessarily doing AI stuff at nighttime or whatever. There's kind of a cyclical workload, which means there's the same kind of heat output, which doesn't necessarily match um, the heating load, right? So you need to match those two things. But with Bitcoin miners, there's no end user, there's no third party. You're either mining or you're not. So you can run it when you need it. You can ramp it down if you need. You can keep it going steady 247 year round. You can play the demand response markets with your grid operator. It's pretty interesting.
Yeah. Yeah. Just curious. So from liquid cooling perspective, is that mostly immersion cooling or
Direct to chip
direct to
is
chip?
the better
Okay.
one. Yeah, I mean, there are immersion cooled setups, but it's not, I don't think it's the future. It's simpler in some ways, but just more complicated and messy in others. So, um,
Yeah, I think
you
it's
know,
it's a niche. It's a niche technology, I think that's what we're gonna find.
yeah, it's cheaper to deploy than your direct to chip, but if you look at the total cost of ownership over the life cycle, and maintenance considerations, and what a mess it is, like it becomes uh, simpler and makes more sense to run sort of water cooled.
Yeah.
Um, so that's mostly what I'm looking at. I think that is the future, and I mean, it is for all compute. I think the rest of the modern GPUs are kind of going that way for various reasons, but um, it's not. I mean, from what I've seen so far, it's not ideal. It's not ideal for waste heat reuse. I think the only thing is, if you're going to be deploying these machines anyway, then why not try to find somewhere to dump the waste heat? But um, you're not leading with the heating value proposition first, which is what you can do with the Bitcoin miners, right? You can basically say, like, you can look for heating applications and then build, a right-sized Bitcoin mine right there, as opposed to every other form of compute where you've got other drivers, and then you're wondering, okay, is there anybody who could be a heat off taker nearby? And doesn't make any sense. That's one of the fundamental challenges, besides unpredictable workload and heat output, and lack of ability to sign an SLA with a heat off taker, and sort of a 35°C outlet temperature. So it becomes a whole lot less useful. Not impossible, just not as interesting.
Yeah, but good luck with your bit mining folks. Not that it's you're right. They have a it's a whole different type of um, risk tolerance and whatnot. And you're right. You can size the Bitcoin rather than have the compute drive what's potentially possible for the off taker.
Yeah.
So yeah, I mean, invariably, greenhouses take up a fair amount of space. This is not something you'd stick near most of the time, not near a major metropolitan area. You got to be within a drive, or a day's drive of a major market for the
Yeah.
produce. But yeah, get it figured out. Well, it looks like no one's coming. Maybe they did drop things today. So
Yeah. It's likely it's usually what has happened if you dial in and there's nobody there.
yeah.
Hey,
Well,
hey,
listen, I'll
folks. I just want to say hi. It's my first time calling in. So I take it there's usually more folks.
Yes, that's right. Yeah, there are, yeah. And there's a couple of individuals who are leading this, so they must have
Yeah, I met Barath at OCP. He invited me to the calls.
right. Cool. Yeah. So I don't know where that memo went out. It might have gone out on, I think there's like I think there's a communication channel or some kind of forum that I must not be following.
It looks like Jamie canceled that. I got an email.
Oh,
Yes.
okay.
Oh, okay. Why not list? Um,
It was still on the calendar though. It's like you had to open it up and then remove it.
Oh, okay. Yeah, I must have missed it.
no worries there.
I made the mistake of turning on notifications for a SharePoint folder that just sent an avalanche of emails into my inbox.
Hey Matt, do
So
you see
it's
any
the
two-phase with Bitcoin?
um yeah it is it has been tried. It is something that the company that I'm working for right now, Mara, is something that they had invested quite a lot into up to, I don't know, say a year ago, but they have abandoned
Was
that
was
due
that
to a
immersion or two-phase direct-to-chip?
two two phase. Yeah, two phase. So um it's kind of on the back burner right now for the future, maybe, but it's not it's not a certainty. So I don't know. There are a number of drivers that sort of made that decision happen that I'm not fully aware of. I haven't really been following it too close, but I know that it's been sort of stuck on the back burner.
I'm asking. I work. We mainly do pumps and heat exchangers and that types of things that are used. But I'm in the part of the business that works with startups. So talking direct to chip, two phase, also a lot of a lot of atmospheric water generation, reusing waste heat, and all those types of things. So the thing that keeps coming up is how two phase is potentially more advantage for heat reuse. So that's the reason for the
Hmm.
question.
Yeah, and I think that's the only reason possibly that it's even still on the back burner. The the possibility of maybe doing sort of vapor recompression and getting higher temps.
Mhm.
Well, listen, guys, I'm going to drop off. I caught your names from the screen. I'll send you a LinkedIn ping, and we'll at least get connected there. And then I assume we pick things up in January.
Yeah.
Looked at January just to see. What is it? First Tuesday of every month? Is it the first Tuesday and first Thursday? Oh, that's the 30th.
Yeah,
There
can't
is one
recall.
on for the 6th, January 6th.
Oh, yeah. Let's see it. Oh, that's interesting.
Perfect. Yeah, I'll connect with you guys too, and have a great holiday. Happy New Year. See you in the new year.
All right, fellas, take care.
Cheers.
Yep.
Yep. Bye now.
Thanks.